Hi all, myself Narender, working as an assistant professor of BSS Mathematics in BB Raju Institute of Technology. Now I am dealing the course of linear algebra and calculus. In this course, I am dealing with the unit higher order differential equation. So in the previous model, we discussed how to find the particular integral for the special cases. So now we are dealing the third case now. Third case is, I'll write the third case, the case 3. If f of d of y equal to q of x, where q of x equal to x power m, where m is a positive integer, it is not for the negative numbers, is a positive integer, Now how we had solved this case, now we'll see here. Now we'll write the particular integral of this one, 1 by f of d of x power m. Now here we have this 1 by f of d, we can rewrite as, so we'll write 1 by f of d as, 1 by 1 plus or minus pi of d. Sir, how we can write this? We'll write an example here. Let us write 1 f of d equal to some d square plus 2d plus 1. Okay. Now we'll rewrite this 1 plus or minus pi of d form. What the meaning of this? 1 plus, I'll rewrite this d square plus 2d. Now I rewrite this equation. This is the I'll write the pi of d, and this is the plus of 1. So now we'll write in the case of 1 plus of pi of d. Let us consider one more example for understanding easily. D square plus 2d plus 2. Let us write. Now here 1 is not available directly. We'll take the what is the lowest degree of derivative. So d square is the highest degree of derivative, degree will be 2 is the highest here, and the 1 then next 0, d power 0. Now we'll take it outside. What is the coefficient of lowest degree of derivative? We'll take it outside. Now we take it outside. We can write 1 plus d square 2d by 2. Now again it is in the form. So what we can write 2 of 1 plus of pi of d. Now where the pi of d will be what? The pi of d will be d square plus 2d by 2. Now see how we are finding this this f of d as 1 plus or minus pi of d is a main step here. Now after writing this one pi of d, f of d is 1 plus or minus pi of d, then 1 plus or minus pi of d into x power m. Therefore we'll rewrite this 1 plus or minus pi of d and whole power minus 1 into x power m. Now we can expand this 1 plus or minus pi of d whole power minus 1 into x power m. You can expand this term. What is the term? The term you can expand by using the sum following case. I'll write for example 1 plus x whole power minus 1. Write 1 plus x whole power minus 1, that is 1 minus x plus x square plus minus x cube and so on, that we can write. So here what is the use while writing this one? It means, so this x power m will be definitely 0 at some derivative. The derivative will be m plus 1th derivative becomes 0 of this x power m. So we have to write this expansion till the derivative becomes 0 of this function, that x power m. So that means that x power m will be 0 at the place of m plus 1th derivative. Now we have to write this expansion up to that x power m plus 1 case. So we'll write for the d case because we have the formulas will be 1 by d whole power minus 1, that is 1 minus d plus d square minus d cube plus and so on. That let us write 1 minus d also there, 1 plus or minus case, that is 1 plus d square plus d cube plus and so on. That now after this 1 minus d whole power minus 2 also there, because we have that powers will be 2 also is available some cases. So in such cases we have to follow this one also, otherwise we are getting some problem with these expansions. Now that also I'll give you for your reference. 3d square. Now 1 plus d whole power minus 2, that is 1 minus 2d plus 3d square minus 4d cube and so on. Now these are the some expansions. So the first step, we'll write this 1 by f of d as 1 by 1 plus or minus pi of d. Then after we rewrite that 1 plus or minus pi of d as 1 plus or minus pi of d whole power minus 1 into x power n. So we have to expand this expansion by using the below expansions till that x power m become 0. While derivating, this x power m becomes 0 at some place. That place we have to expand this. Okay. So now we'll see some models on this case. After this, we'll go for the next level. Now we'll write one problem on this. The problem: solve the differential equation d square plus d plus 1 of y equal to x cube. Now d square plus d plus 1 of y equal to x cube. Now this is the given differential equation we have now. The given differential equation, we'll write the given differential equation is d square plus d plus 1 of y equal to x cube. Now this is, I consider, the one. Now as it is the same format, we have to follow the auxiliary equation. F of m equal to 0, then f of m equal to m square plus m plus 1 equal to 0. That is, I can write the roots of this equation will be, we have to follow the quadratic expression method, minus b plus or minus root over b square minus 4ac by 2a. That I can write minus 1 plus or minus b square, that is 1 minus 4ac, that is 4ac, that is 2a. So minus 1 plus or minus 3i root 3i by 2. Therefore minus 1 by 2 plus or minus root 3 by 2i is the roots. So therefore whenever we have the complex roots, we have to follow the complementary function case. The complementary function is e power minus r 1 by 2x c1 cos root 3 by 2x c2 sin root 3 by 2x. Now this is that your complementary function. Now after the complementary function, we'll write the particular integral. The particular integral will be 1 by f of d of x power cube. So that is 1 plus d square, I rewrite directly into x cube. Now what actually we can rewrite as a 1 plus or minus pi of d form. Now what is a 1 plus or minus pi of d? That is 1 plus, I'll write in the terms, is a d plus d square into x cube. Now this is that, now this I can write 1 plus d square of whole power minus 1 into x cube. Now we can expand this using the notation. Already we know that 1 plus d whole power minus 1, that is 1 minus d plus d square minus d cube, and continue this. Now in place of d, what we have here, d plus d square. Based on that expansion, we'll write 1 minus d plus d square plus d square whole square minus d plus d square whole cube. Now I am stopping this because the x cube derivative is 0. We'll write the derivative of x cube. Dx cube will be 3x square. Again the d of 3x square will be 6x. Again the d of 6x will be 6. Again the d of 6 will be 0. That means first derivative, second derivative, third derivative, fourth derivative. The fourth derivative becomes 0. That means d power 4 of x cube is 0. D power 4 of x cube is 0. That means in this case, we cannot write the d power 4 above terms. We have to write the d power 4 and d power below terms. Then we can finish the problem. 1, we can expand this d plus d square. We can expand this d square, d power 4 plus 2d cube. All the terms are required. The d power 4 also 0. Now in this case, d cube minus d power 6 a cube minus b cube, a cube plus b cube plus 3ab square, that is minus 3 into a into b square, that is 3 d power 4 minus 3 into d power 5 and so on, that into x cube. Now Here I am not required this d power 6, d power 5 also. I required only the terms up to d power 4 only. Now d square, this d square will be cancelled here. I'll write 1 minus d into this 2d cube minus d cube, that is a d cube. Now d power 4 minus 2d4, that above d power 4 is also not required for us. Now we can expand this x cube, derivative of x cube will be 3x square, derivative of 3 times derivative of x cube will be, first derivative will be 3x square, next derivative will be 6x, other next derivative will be 6, that is plus 6. The derivative of 4 will be the 0, no need to write this. Now therefore the particular integral will be x cube minus 3x square plus 6. Here you have to observe one more step here. I am writing based on the terms we required. This x cube will be, whatever the x cube we are writing here, this x cube will be 0 by derivating. At what derivative is become 0, we have to identify first of all. So after identify that, we have to write that up to that terms. So it is a 0 at the place of 4th derivative. So that's why I have considered up to the 4th derivative only. That other derivatives I am not considered, but in the expansion we'll write, but the next step we are not considered because the d power 4 only 0, the above of the d power 4 because already 0, because the d power 4 is already 0, we know that. So the 4th derivative of x cube will be 0. In such cases, then we can stop the problem up to d power 4. Now we'll write that the general solution of this problem will be, the general solution will be CF plus PI, that is equal to e power minus 1 by 2x of C1 cos root 3 by 2x plus C2 sin root 3 by 2x plus the particular x cube minus 3x square plus 6. This is the particular integral. Now we'll solve, I'll give some models to solve these problems. So these are the 3 cases. So till now what we discussed, now I'll give some models to you to solve this case. D square plus d of y equal to x square plus 2x plus 4. The second case, d cube minus d square minus 6d of y equal to 1 plus x square. The third model will be d cube minus 2d square plus d of y equal to e power 2x plus x square plus x plus cos sine 2x. Now see this problem. I'll give some clues for this problem. Here till now we are solving this f of d of q of x. The q of x will be, the first case will be the e power ax we solved. Next case will be sin ax and cos ax. The next case will be x power m. Now 3 cases we solved. These are the basic cases for this in the case of non-homogeneous terms. The other 2 cases is also based on this 3 only. So first of all, you are able to solve these 3 cases. You can solve the next 2 cases easily. So here you can observe this. This is the first case. This is the third case. This is the second case. So in one problem, we include all the 3 special cases terms. So better you have to solve this problem. You are able to solve all the 3 cases yourself easily. Now these are the 3 models for your reference. And till now we have discussed the 3 cases. The remaining cases we'll discuss in the next model. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.